Hey guys, just a second because I'm trying to figure out why something is not working with my printer. So give me a second. So please enjoy the music. I guess I'm just gonna leave the printer like that. For some reason the printer does not want SD card. Oh yeah, I don't know what to do. So I guess we're gonna start now. So let me change my scene. So basically what we're gonna be doing today is I wanna put some LEDs on my 3D printer. So basically um there is an option for a Marlin firmware where you can have an LED strip controlled by the firmware using G-code. So in order to do that, you actually need to use transistors. Here I have a bunch of them that I had laying around that I got for like $5. It's really like a lot of them, like at least 200 of them. But the thing about these transistors is that every little box has different type of transistors, and every transistor has different it has different specifications. So that means I have to check all of the transistors to see whether their specifications is gonna fit the what I want to do. So if you guys don't know what a transistor is, a transistor, if I can draw it here and camera, um so a new notebook. A transistor in this case, from what I see, we're gonna be using BJTs. So BJTs basically kind of look like this in the circuit. You have one lead here, then you have these, something like this. Or actually, I think this was a FET AT. So you have the collector, you have the emitter and base, and basically you'll have a current flowing through here that goes from here to here that we can call IB. Then we're gonna have a current coming through here, which is gonna, and if this current is the same as this, then this is gonna be the same IB, but if it's different, then it's, so this current that we input here is gonna control the current that basically passes through here. So that means you can actually switch certain devices based on the current that you input. From there, what we have to do is that every LED strip basically looks like this. At least the ones that I have look like this. They're gonna have say a line with 12 volts here. Line here with 12 volts. Then this 12 volts come in here. Then gonna have shit. I don't know diode now. Then put a bunch of them, and then it has 3 separate leads. That's something along the lines of that. So basically, we can put it as a separate because it's gonna be basically like separate diodes. This case, current is gonna that 3 diodes. Then we're gonna have the transistors that we're gonna put in. So we can say this is a LED, this is another LED, this is another LED. So this is gonna be, let's say, blue, this is gonna be red, and this is gonna be green. So when you have all of them three together, you're gonna have white. When you have this, you're gonna have one color. When you have this on, you have another color. So that means we're gonna have basically one transistor for this one, another transistor for this one, and another transistor for this one. This all will jump here, go here, jump here, and then these three will be connected to the Arduino. And when you connect it to the Arduino, this is supposed to be basically these LEDs. We have to connect them directly to ground, because ground is the only lead that we can actually switch. This has to be 12 volts and we cannot change it. So basically I gotta make this circuit with the transistors so we can connect them then to ground. I have some PCBs that I can use, but this we have to also add leads to connect to the Arduino. And if I can pull out Marlin firm, I have one. Um, it froze? Don't tell me that it fucking froze. Ah, god damn it. This is. I'm gonna transition back to the. Because this just froze. So you guys basically missed everything that I said, and I don't have any other webcam. This is bullshit. But I think I can do it on GIMP. Just gonna remove the. Gonna put the. So what I was saying before is that if I have GIMP here. This is shitty. I don't know why that happened. I think it has happened before. New. Um. So a transistor basically for BJTs, it looks like this. Uh, you have the collector here. You have the collector here. You have the base here. You have the emitter here. Now, based on the current that you send through the collector, let's call it IC. You can change the current that goes through here, which is B. Sometimes you're gonna have IE, but that depends on if B and E are different. It's messy, but usually it's the same thing. B and E, you can switch them around and it's gonna be the same thing. So for our LEDs, it's gonna be basically this circuit. We're gonna have a 12-volt source at the top. It's gonna be our main positive. Gonna come down, split into 3, and then we're gonna have the LEDs here. We're gonna have our LEDs here, and then we have the transistors here. That Then we're gonna have here the bases. Have the ground. Sorry for the shady cat here, but that's much as I can do. So when you send a signal to this, through this pin, which is gonna be connected to the Arduino, current is gonna be able to flow. So if this is, let's say, red, let's just make it blue because it's almost a B. Let's make this one red and one green, so I can pick colors actually. Blue, red. So when you have the current, you have basically, if you have none of them switch in here, and they have no current going through it, what's gonna happen is like it's gonna be just off. If you have all of them on, it's gonna be white. And if you have, let's say, only this switching, it's gonna be blue. If you have only this switching, it's gonna be red. And if you're gonna have this switching, it's gonna be green. Now if you combine different one of them, it's gonna be the color, the mixed color of all of them. Let's say for red and blue is gonna be purple, and for green and red is gonna be yellow. So this you can actually switch with the Arduino on the ramps. So you can connect it to the pins in the servo pins that you have at the side of the ramps, and then you can switch these three. So basically you can actually give a G code which you can put in the firmware, and then you can switch this depending on what your printing is doing. So for example, if it's starting to print or heating up, you can say like when it's heating up, it's gonna be red. When it's done heating up, it's gonna be green, and then when it's printing can be white, and then at the end when it's done it can be blue. So you can actually just look at your printer from across the room and know that what your printer is doing based on the color of the LEDs. So let me see. I don't think I have firmware here, so I can go into. And then I can check the part that says that talk about it. You can actually go on. You can actually go on GitHub and actually look at the code. So I'm gonna look for config, which should be at the top. So config one. If you scroll down a lot, I think it's at the end. You can see this, this part. Says extra features, and it says increase PWM, find this of PWM, temp stats LEDs, and then RGB LED strips. So this part over here. So you can basically specify which pins you want to use in order to switch the LEDs on and off. So for instance, they give you the PWM capable pins, which are 4, 5, 6, and 11. And these are actually the same ones I think that they use in the servo ones. For example, where if it's here. But they say it's somewhere here where they might be the same pins, because for servos, you actually need to PWM the pins to be able to switch the servos. And then the good thing that you can do is actually be able to go from the luminance value from 0 to 255. So that means that you can actually dim your LEDs depending on, let's say for example, if your temperature is at 0, you can have it, I mean at the lowest, let's say it's 25, which is room temperature, you can have it at a really low dimming value, and then when it's at the proper temperature that you want it to be, you can have it at the highest value. So stuff like that. And it says here that you have to use a MOSFET chip with the line, blah blah blah. This is basically our transistor that we're gonna use, so we don't have to connect it directly to the pins or whatever. Here also you can use RGB or RGBW. Some LED strips actually have a separate line for white, if I'm not mistaken, so that means that you can also switch the white, so that means it will require you to have another pin. In this case, I'm just gonna use 3 pins, which is gonna be these 3, and that's it. So now let's go back. Now that we know our CAD here, that we know we're gonna connect it and how we're gonna connect it, we can actually go to our schematics. See how we're gonna do this. So I couldn't show you guys because it actually froze. The camera froze, but actually I think it froze showing the transistors. So let me show you. So these are the transistors or BJTs that I have now. There is two type of transistors. There is MOSFETs and there is BJTs. What I have here, I think, if I'm not mistaken, is mostly BJTs. MOSFETs and FETs, you use them a lot for different applications, but for this case, I don't think we use MOSFETs. We're using only BJTs. I have some PNP, NPNs, and so on here. Now all of this that you see in the screen are all of the transistors that I have here. So we can switch again to screen, and we can see that I have here all of the schematics for all of the transistors. So I'm just gonna check around and see the values for the schematics. Just making sure that my transistors are not gonna burn. You see, I knew I was drawing it wrong. I draw it completely. Collector current continues 6. I am not sure how much current I'm gonna. So for some reason my display seems to be bugging. When I move it, it's kind of shitting its pants. But I want to check the continuous current that they can do. So this can do 200 milliamps. This is NPN can do 600. This can do 200. It's not good. This can do 600. This can do 600. The most current we can do. No. This current is for the collector. What about the what about the base emitter current? Huh. Problem is that there are so many transistors that I have here that I don't know which one to choose. I could literally just plug them in and try and see whether it works with them or not. That would be very responsible. I'm just gonna wing it and go and Google it and see what people. Let me see. Let me see what they say. They say that you have to use MOSFET, but I am not using a MOSFET. IRLP 16 amps. I'm not at maximum I think I'm gonna do like 1 amp. I don't think it's gonna take that much current. I would like to do some tests. See how much current will I need, because the voltage for most of these transistors, the voltage doesn't really matter because I'm never gonna go to the maximum voltage from what I can see. But for the first I'm gonna use an NPN, so this PNP. This is this PNP. Thing is that the PNPs are not great. NPN. Fuck. This looks so. I'm gonna try with the first one. Cancel it. So I wanna do a measurement and see. So I have No, I'm not gonna build a fucking fidget spinner. And I gotta get an LED strip so I can test how much current is going through it. And I'm gonna see if I can power cycle this fucking camera and see if I can get it to work. It just fucking froze on me. It's annoying as hell. It works for like 5 seconds and then this is. Cause I have used it before for. So let me see. This is dumb as hell. It makes no sense. Um, gonna disconnect. Ah, fuck off. Uh, I'm gonna get my measuring device. I'm gonna measure what's the current when all of the when one color is triggered and when all three colors are triggered, just to make sure that I know the amount of current that is gonna need. Ryan, did you go to Hawaii? Or are you still here in the States? Okay, so this is so annoying because really wanted to show you. Fuck, and this camera bullshitting me, scaring me really fucking. I have here my LED strips, LED strip, just one of them, which actually has two of them. I could divide the current that I measure. Two. I need some cables to. I changed the cable on the camera. Let's see. Fuck it. So I might have what? Guess it's gonna function. So guys, what the Better than nothing. Better than nothing. Uh, that's fine, actually. Bad quality, but pretty shitty. But it's gonna do. It's gonna have to do. Wasting time on it too. Whatever. I'm just gonna put it like that. Guys are gonna have fun. There you go. So what I'm gonna do now is how much current it needs to run these two LED strips. I'm actually gonna use two per side, so I'm just gonna light up three sides, so that means it's gonna be basically this whatever I measure multiplied times 3. That's it. So yeah, black is supposed to be 12 volts. Positive. Wait, it is not crazy. Then I'm gonna do this the one, but switch my current up. So now I switch to 10 amps, and it says that it's taking 0.04 amps. That means that is of 20 minutes. So we're basically using, so for blue we're using 0.04 amps of them. White, which is all of them together. So for red, we're gonna be using 0.03 milliamps. I mean 0.03 amps. Sorry. For green, 0.04. It should be between red and blue, so it's gonna be maybe like 0.045 something. Just can't round it. And for white is gonna be all of them together. Gonna be 0.1 milliamps. 0.1 amps. Basically, if we run basically for each color, let's say for blue, we're gonna have to multiply 0.04 times 0.04 times 3. So that will give us the amperage that we require just run one color. We just want to know one color because from there we can actually figure out how much current we need just for each of the BJTs that we're gonna use. So I'm gonna disconnect this real quick. I'm gonna focus on the math now. So I have that. That's the values that we got from the measurement. Hey Aspi, how you doing? This is the values that I got from the measurement. From there I can multiply each of them by 3 and I get the maximum, or I guess the average amperage that I'm gonna require for the strips that I need. So in this case 0.0 times 3 is gonna be 0.12. And the other one is gonna be 0.3. Gonna be 0.0. So from there we can get an understanding of how much amperage we need on average just to run these LEDs. Then we can go to the schematics and see the values. So of characteristics, on characteristics. So IC milliamp DC blah, this is current collector base of the base. The base is 15 milliamps. So this is saturation voltage. This gets so complicated because you got curves, you got this, you got that. Let's say you gotta add a resistor. I don't want to add a resistor, you know. But one value that I need is beta. And beta is the ratio between the current in the base and the current in the collector. So we can figure that out, I guess. Small signal characteristics. This is not too useful. Switching characteristics. This is if you wanna do logic, but I don't think you wanna do logic with BJTs. Shit. This is the off characteristics. It means that if it starts going there, then it's gonna be off, and it's not gonna work. Then on characteristics, so 150 milliamps on the collector. Wait, so it says you need 15 milliamps on the base to make 150 milliamps on the collector, and 50 milliamps DC on the base to make 500 on the. Actually, that's not too bad. Could do that. What's the? Do any of you guys know what's the amperage coming out of the pins of the Arduino? So they say that VCC current and ground pins, it's 200 milliamps, and then they say that it's 40 milliamps for so how much 40 milliamps will give us? Let's figure out the ratio for this one. So we can figure out the ratio between IB and IC with the formula IC is equals to beta IB. We can divide IB both sides. So IC over IB will be equal to beta. So that means that if we take IC, which is 500 divided by 50, it's gonna give us 10. That means that beta is gonna be equal to 10. So that means that if we have 40 milliamps coming in, we're gonna have 400 milliamps on the collector. and we said that we needed it. We said that we needed 0.12 amps. Um, that's gonna be, at least for this one, for blue, it's gonna be 120 milliamps. But we can actually get 400 milliamps with this. So that means that we're actually doing pretty good, because the current that we give it is just gonna use whatever current we give it, and then just let everything else go to ground. So we might be safe using these ones, because we're not really cutting it short when it comes to current. Now that's fine and dandy and everything. I wanna see the maximum voltage that this can use. So I think it says here that maximum, I'm not sure what this, if it's, this is amperage, what. Um but what are the maximum values for voltage? Oh yeah, this is the maximum radius. So for the collector emitter voltage is gonna be 40. No, I think we're safe. We're pretty safe. And the emitter is gonna be 6 volts. In this case, it's gonna be 0 volts. And the collector, we're basically just gonna be having 12 volts. Wait, we're gonna, for the collector we have, yes sir, we have, no, for the collector we have 12 volts. For the emitter, we're gonna have 0. And for the base, does it say the maximum voltage for the base here? I don't think it does. Yeah, it says collector base voltage, then collector emitter voltage. I'm thinking we're pretty safe here, but we actually can go and burn maybe one of these transistors. So in this case, if we wanted to, we can actually burn it. I don't care. I have a bunch of them, so this is gonna be the first one, which is P2N22222A. Actually, this one. Now this is a transistor. I'm not sure if you can see it, but this is a transistor. And what we can do is that we have here the base and the collector. Now we have the base in the middle. We have the collector on here, and we have the emitter on here. So that means we can bend these pins slightly. Now, what I'm gonna do also is pick up an Arduino and test it with the Arduino first, and we can see if it actually catches fire. If it doesn't and it actually turns on, then we're safe. So let me get an Arduino Uno and I'll be right back. So I have an Arduino here, and I'm gonna also measure later on what's the current going through it. So I really don't wanna burn something up. So gonna load up Arduino. And then we're gonna look for Blink. So examples, basics, Blink. Now Blink just blinks an LED. That's it. And the pin that we're gonna be using for Blink is gonna be what pin are we using for Blink? What the fuck? Which pin are we using for Blink? If I'm not mistaken, it's supposed to be 13. Yeah, pin 13. So here we have pin 13 here. I connect this one. So we're connected to the gray one. So our base is gonna be the gray one, running at 5 volts. Shit, this doesn't stay. Yeah, I'm gonna have to. Don't tell me I'm gonna have to. I have to flash. I have to flash the code inside of. Hopefully this works. Because Arduino tends to be a bitch on Linux. So no port. Try and do it. Ah, you son of a signal segment. Close it. Now open it in uh, I'm gonna open it in super user. There you go. That ensures that it's gonna work. So Arduino Uno port USB. What the fuck? Signal segmentation for error compiling for what the hell? What? Am I shorting something? Something's this error compiling for that. Why? Why is it doing that? Hey. Can someone figure out why is it doing it? Like, don't tell me it was a fucking update. Oh my god. What the fuck? Oh my fucking lord. Please, please. So it's an issue with Arch. Oh my god. These people are playing with me. What version did they? Oh. It's failing to upload the sketch because the compiler is fucked up, and the compiler is fucked up because these people fucked up doing the packaging of it. That's why. People are fucking stupid. So I gotta find another version of Arduino, but from another place. I'll try to do the Git one. This is gonna be a long stream. This is gonna be a long stream. Oh my god. Yep. This is gonna be a long stream. So anyways, I'm gonna try to wire this, man. I'm gonna put this Arduino to the side for now. Connect it to the base. Then we need bolts. The bolts is supposed to be connected to here. Then this one is gonna be, oh shit, it's shorting. This is supposed to be connected to, yeah. Then we have this connected to ground to the base. There you go. I can connect my power supply and hope it will. That is leaking. Fuck, it's leaking power. Oh shit. Sorry. So, um, it's leaking power. Oh no, it's not. It's it actually works. I think because if I press with my finger, it actually lights up. I can barely see it in the camera, but it press it with my... So if I use my body to connect, maybe. Oh, it actually turns on. I connected with my body to 12 volts. Oh yeah. So yeah, it's 75% compiled. Actually downloaded, so gonna be waiting here for a while. But anyways, at least I know it works. Let me see. Does it float or something? Yeah, I think it's just floating. That's because if I connect it to any pin in the Arduino, it's floating. It doesn't really know whether it's grounded or what. So I can pick the ground pin and try and see if I can get it to... Yeah, I think we're just gonna have to connect to the two grounds. So the ground from the power supply and the ground of the Arduino. So that means I'm gonna have to connect to the ground of the Arduino, and technically it's gonna be the same ground. If I connect it to the 3D printer, it's gonna be the same ground. So it's not gonna float like this because it's gonna have the same ground as the Arduino. And then I'm gonna put 12 volts from the power supply, and 5 volts are gonna come from the pin of the Arduino. So hopefully it doesn't float like that, where a slight bit of current can... like as long as it's not completely floating like this, is it's gonna... which is not good. So anyways, I'm just waiting here to see if I can finish installing. Oh, finally. But let me get some water meanwhile. Actually, you know what's better than water? Beer. So while this compiles, I'm just gonna drink a beer. That's good. Oh damn. Finally, fuck. I'm running again. What the? Oh no. Oh lord, this fucking crashed. Fuck Linux. It should have streamed from Windows. Hopefully it works. Let's see. So they said that the issue comes from AVR VR slash GG. So they said to downgrade to AVR GC. So they said to downgrade to 6.3.0. 7.1. Fuck this. Let's install this so I can downgrade this thing, and then when I downgrade this thing, I'm able to um There you go. This a 6.3 works from Cache. Um, I'll say 2. There. And now let's see if it works. It's gonna say there is an update, but whatever. It can fuck it. So we can test it. Works. See, sometimes you gotta be smart. You gotta know what you're doing. You can get things done. So we're gonna go blink. Wanna select uno, B. Really. Oh fuck. It did work. So we're gonna connect to pin 13 here. See properly. I can't see properly which one it is. I think it's this one. And also what we gotta do is connect the ground. I need another jumper. I'm gonna connect both of the grounds together. In this case, this is gonna be ground, like this ground, and also ground, which is the same ground as the. See, now it works. For some reason, it's just loading here. It's showing. So you see, guys, now it's working. It's working. So now we're basically using the transistor to flash the LEDs. I want to see if it's hot. It's a little warm, but it's not too bad. I'm gonna connect all of them 3 to it. Even though I know that it can work, but I'm not really gonna connect 3 of them together like that. So I just wanna see what's the worst case scenario for these 3. So connecting the red one works. Connecting this blue one works. Now if I connect these 2 together, I get yellow. If I connect these 2 together, I'm gonna get purple. If I connect these 2 together, I'm super. What do you get when you connect? type of blue green. Connect this. White, which works perfectly and is bright enough. Perfect. This is perfect. I didn't. And the funniest thing is that I didn't have to read the whole. But nevertheless, this is actually pretty cool. So that's fine. Um, Pretty cool. One thing that I completely forgot was to share this stream. So I'm gonna switch to my camera. Um, okay. I'm just gonna switch to my camera and I'm gonna. Actually, while I'm doing that, I'm gonna. Yeah, that's another thing I'm gonna have to be concerned about is the fact that me, I'm just gonna leave the first. One thing that I have to be concerned about is the fact that I have to remember to plug in both of um the grounds together. But even since I'm gonna be using the ground for the Arduino, which is the same as the ground of the same power supply, I'm gonna be just using the that ground. But yeah, I can technically I could get away with using just the ground of the power supply, which is gonna be fine. It's in fact gonna be better for me. I'm gonna make this LEDs flash way faster. And Go for it. There you go, seizure mode. Oh god, oh no, I'm gonna have a seizure. I'm gonna have a seizure. Oh no, please, no, no, I'm gonna have a seizure. I'm gonna have a seizure with this thing flashing so fast. Oh Lord. Please, Lord, save me. I'm gonna have a seizure. This is flashing too fast. I'm gonna have a seizure. Lord, please save me. I'm gonna have a seizure. I'm gonna have a seizure, Lord. Please. So this is what we're gonna do now. We're gonna pull three more of those and a 2 and 2 and damn, that beer is good. And we're gonna make a PCB. So how we're gonna make a PCB? I don't know. We're gonna make a PCB. Also, another thing that I wanted to test is dimming and how it's gonna work when you PWM it. For that I'm gonna look for examples. I'm gonna look for fade, and then in fade I'm gonna pick pin 9 in this case. I'm gonna flash it. So then I have to connect this to pin 9, and when I connect it to pin 9 it's actually gonna dim up and down, up and down. So let me do that. I reckon I can connect it. Oh shit, don't connect to that, please, please don't short. Okay, so now it's actually dimming. It's going up in intensity and going down, going up in intensity and going down. Pretty cool. How many points perfect? It's weird because it kind of gets down to a certain point, then it kind of like, I don't know. But what we're gonna do now is we know that it dims. Let me see if it's hotter than. It's actually pretty cold. We know that it dims. We know that we can flash it and turn it on and turn it off and blah blah blah. So now what we're gonna do is just put everything in a small PCB and just work with it. In this case I'm gonna see what PCBs I have that I can put it in, like a really small one, so I can I don't have to deal with like big PCBs, so I can just throw it somewhere, put the, like wrap it on tape, put it somewhere and just forget about it, and then control it with the freaking thing, the Arduino. So let's just do that. I'm just gonna disconnect everything and get rid of everything here. We can bring it back later so we can test it, but I want to finish this. Since I know this works and then the transistor works. That was my main concern, is the transistor working. And actually the transistor worked pretty well, because I guess it was because it wasn't getting to its limit. It was like really below its limit, but at the same time it was higher that the threshold voltage in order to be actually on. So here are my wires. I cannot find my PCBs. Gotta see where I put my PCBs. So I found my PCBs, and what I'm gonna do is take this one I have here and split it in half because I don't really the whole PCB. I'm gonna do some dry fitting and see how it fits. So in this case, if you have it this way, then they're never gonna go in. Gotta kind of like split the legs. And put it in. That's what I'm gonna split it as much as possible, so the leads can have some. So how many pins do we have in between? And 8. We have 8. We have 3. Um, that means if we do 6. This one. Right about here. That's. Then I can put another one. That's. That means I can. They're kind of gonna look like that. And I can solder them. Solder here. I don't know, the other way. And then we're gonna solder the base wire, which is gonna be one here, and one here. In this case, I'm gonna maybe do one here, and then right next to the base. So that's gonna be fine. I'm thinking, so I don't waste my precious wire here, I'm gonna use some other wire. Thing is that for the amount of current I can actually, the amount of current that we're passing through, I could get away with using this thin wire, which is the wires that are inside of Ethernet cable. So what I'm gonna do is just take this dark blue, just so I know. Actually, you know what? This is blue, this is red, and this is green. So it actually works perfectly. I could have one for green, one for blue. So here we go. We have green, we have blue, and we have red. So I think I'm gonna cut them down to length to be about 2 feet. Gonna be okay. Once they are the same length, we should. And then for the other wires that are gonna go to 12 volts and ground, I'm gonna use the thicker wire. So I'm gonna be because this wire is that plug into a pin. So I'm gonna use my um now what I'm gonna do is get my soldering iron and put it to heat up and solder these wires. So I I think I should be cutting 3 sizes of this certain length. So to measure, I'm just gonna I'm just gonna do about the size of my back. And I think about it makes no sense to me for three different wires for ground, but I can actually just because it's gonna be the same ground, so I basically can bridge all the grounds together, and then when one of them flips on, it just connects to the same ground either way. So I just have to cut one ground basically. I'm running out of my poor wire. Wire is amazing. Running out of it. Shit. Make a bridge here. That is gonna. I think the first thing that I'm gonna be doing is uh gonna be their faces. So the first thing first, I put this here. Iron is hot. So how I'm gonna be soldering them is tacking them in place with a little bit of solder, and then um I'm gonna push it up and heat it up, and then leave it where it's at. So for box, because this has So that's the first one. Back up. Ah, fuck. When I saw they were the that's the last one. So I wanna now solder the wires that are gonna go. In this case, the no. And the order that they use: red, green, and blue. That means we're get it from the red, green, and blue. And that tape. soldering of these wires are gonna. Oh, no, 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 no. Where is literally solder repair. I guess we're not using that one. That's all. Guess I'm taking it. I gotta find another wire. Use the black. But meanwhile, wanna take this. I'm gonna use my scissors to place it. Winner, fidget spinner. That looks like it. Now I need and you can see it the same way I see it. And that's pretty. Moving on. My first trans um Uh, uh, my videos were this boring. But for live streams. I reckon what I'm gonna do is use my black wire to make it's gonna cut. So yeah. Because hey, Lennon. Lennon. They're now Army Man Lennon. My nigga Lennon is in the house. How's the army, Lennon? These wires are better to solve. Side. Now for the last one. And at first, how long has this stream been going? Looks so fucking bad. This is That's what it is. It should. That it's going to. Now we can actually test it and see. For that, I'm gonna be using lock connection. and the block connections will allow me to not have to having to grab wires and shit. Pretty good, can't complain. They're pretty cheap, $5, get a bunch. Very handy if you're doing wiring and you. So let's go. So what I wanna do is take a marker, mark the what color I want each. If I can find a marker. Here. Uh, barely fucking. Oh, what's that? I'll move this steering iron away. In this case, we're gonna. No, 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 no. Oh, no. It's done already. Streaming forward. This will move further. Uh, this wires I gotta. Then basically it's blue, green, red. Shit. Last one is so I'm gonna take my power supply here and I'm gonna attach it 12 volts positive line right here. That's it. Then I put my, where did I put my Arduino? Uh And then we're gonna open Arduino. Starting. Um, so we're gonna get fifth, starting. Uh, 12, 11. It's gonna bring a pin high, another, and basically brings one high, then the other one low, then one high. So it's gonna basically, if this works properly, this is supposed to show one pin going red and then turning off. Then actually let me, then the other one is gonna go blue and it's gonna and green and shut off. The order really does not, that's important. So I am gonna need more jump. 13, 12, and 11. Nice. We can connect the power and now just as I describe it, it's actually doing the same thing I said. It's turning them on and off, just switching between colors on and now that's thanks to this. So that means basically means that the transistor circuit is working properly. Now what we're gonna do is combine some of the colors. So in order to combine some of the colors, I'm gonna another line here. Paste it. Then we're gonna have 13, 12, and 11. 12 all at the same time, and then like they're gonna turn on together and then they're gonna turn off. So that means we're gonna have white, play, and then I'm flashing now, and we're gonna see that there's gonna be one where it has white, white, red. Then at the top, then this is red, this is green, this is blue, and this is white. So if we wanna add, I'll say yellow and pink. Let's yellow. In order to make yellow, hash, we're gonna get rid of blue, which is 11. 11. Get rid of 11 here. Flash it again. So after white, we're gonna have yellow, blue, green, blue, white. See, there you go. Not too hard. Um, let's say we wanted to make purple. Purple is blue and red. So same thing, but we're gonna get rid of green, which is 12. And if we get rid of 12 and then flash again, after this one, we're gonna have purple, white, yellow, and then purple. See, there you go. Now if we want to have a combination between uh, blue and green. So after the last one we added, the combination between green and blue, but purple, like a lightish blue. Now if we change the brightness, then the brightness depending on the color, then we're gonna get when colors are more mixed. For example, when you have like a higher level blue and lower level like red or green, how different. But yeah, I think this circuit basically ready to be put action. The only thing that I need to add is it to the logic of the Arduino, and after that I think we should be good to go. So thank you guys for watching. Hope you guys have a good night. Thank you for again. The circuit was basically this. Just draw this and again this is we draw the circuit, and then we just took some components and made the circuit just switches different colors. Crazy. So then we can say this is blue, red, green. So the switching from the Arduino is gonna switch this transistors. That's pretty much it. Even though I think yeah, this is what we did. The LEDs, transistors, going to ground. That's it. They're pretty bright, and then we're gonna be able to control the brightness. So in one of my videos coming up next, I'm gonna be dealing with how you can actually control the LEDs through your 3D printer by connecting it to the ramps. So yeah guys, I think that's pretty much it for this. I hope you guys have a good night or good day, and yeah.